This is solving quadratic equations by completing the square. When we're completing the square, we're adding a constant c to an expression that's already in the form of x squared plus bx, so that x squared plus bx plus c will be a perfect square trinomial. The way we do this is we first find 1/2 of the coefficient b. So our b coefficient here, we cut it in half. Then we square that result and add that to our x squared plus bx. Then we can factor this resulting expression as the square of a binomial. So it will become x plus half of whatever b is, quantity squared. So let's see how this works with an actual problem. So here we have x squared plus 6x. And we want to complete the square for the expression and then factor the trinomial. So by completing the square, we're going to be adding a c number here to our expression. So the way we decide on this c value is we want to take half of our b value. So 6 divided by 2 is 3. And then we want to square that number, and we're going to get 9. So we're going to make our expression x squared plus 6x plus 9. Now this is a perfect square binomial. So I know that 3 times 3 gives me 9, and 3 plus 3 gives me 6. So x plus 3 squared equals x squared plus 6x plus 9. And here is my perfect square binomial. So once again here I'm going to add a c value on, and the way I decide on that c value is I take my b value, -9, and divide by 2, and I'm just going to write that as -9 over 2. And then I'm going to square that number. So it's going to become 81 over 4. That's going to be the number that I add on to my expression. So x squared minus 9x plus 81/4. Now, this is, a perfect square trinomial because x minus 9/2 squared, quantity squared, will give me this expression, x squared minus 9x plus 81 over 4. Because if I square this guy, I get the 81/4. And if I add -9/2 and -9/2, I will get the -9. So how does this help us to solve actual quadratic equations? So let's see where this would actually come in handy. So in example 2 here, we're solving a quadratic equation in the form of x squared plus bx equals d. So right now what I care about is this first half of the equation, the x squared minus 16x. I want to add a value onto that to make it a perfect square binomial. So in order to do this, I'm going to take half of my b value, which is -8, and then square it, and I get 64. So I'm going to add 64 onto this x squared minus 16x. But if I'm adding 64 to one side of an equation, I also have to add 64 to the other side of the equation. So this guy can be factored as x minus 8 squared. Because -8 times -8 is a 64, and -8 plus -8 is my -16. Over here, -15 plus 64 is going to give me 49. So I'm going to do the square root of both of these. And x minus 8 could equal 7, because the square root of 49 can be 7. But x minus 8 can also equal -7. So if I solve both of these, I get here plus 8, x equals 15 is one solution, and plus 8 plus 8, x equals 1 is my second solution. All right, let's take a look at another example. So this one has our equation already in the form 2x squared plus 20x minus 8. So the first thing I notice is everything in here can be divided by 2. So 2x squared divided by 2 gives me x squared. 20x divided by 2 gives me 10x. Negative 8 divided by 2 is negative 4. And 0 divided by 2 is 0. So I've just simplified my equation a bit by dividing every single term by 2. Now what I'm going to do is I'm going to try to put this guy in a form where I can add a c value here. So I'm going to get rid of this minus 4. I'm going to make this x squared plus 10x equals 4. And I'm going to find a c value that I can put in here to make this a perfect square binomial. So 10, I'm going to cut it in half. 10 divided by 2 is 5. And then 5 squared gives me 25. So that's the number that I want to add in here, 25. But I have to remember to add it to both sides, because whatever I do to one side of an equation, I have to do to the other. So this one will square perfectly to x plus 5 squared. Sorry, it will factor perfectly. And this will become 29. So if I do the square root of both sides to get rid of my square here, I have x plus 5 could equal positive square root of 29, or x plus 5 could end up equaling the negative value of the square root of 29. So in this case, I would want to make sure that I use my calculator, because I'm going to subtract 5 from each side. And this will cancel out here. But I'm going to use my calculator to do the square root of 29 minus 5. And they want us to round our answer to the nearest hundredth. So the square root of 29 minus 5 is close to 0.39. So that's my first solution. And the negative square root of 29 minus 5 is closest to negative 10.39. So there are my two solutions. All right, let's take a look at a couple more examples. All right, so here we're being asked to find a minimum and a maximum value. So the first thing I'm going to do is look at this one here. I notice that my a value here in front of the x is a 1, so this guy is going to be opening upwards, which means I'm going to be finding a minimum value. When it opens upwards, I'm going to be finding a minimum. So what I'm going to do first here is try to actually set this up in that x squared plus bx form so I can complete my square. So I'm going to take this minus 1 here and add it to the other side. So I'm going to have y plus 1 equals x squared plus 4x. Actually, I'll leave a little bit of space in here. Okay, so I want to complete my square. So here's my b value. I want to take half of that, which is 2, and then square it, and I get 4. So I'm going to add on 4 here. And this is going to become a perfect square binomial, x plus 2 squared, because 2 times 2 is 4, and 2 plus 2 is 4. And over here I now have y plus 5. I want to get y back to being by itself, so I'm going to have y equals x plus 2 squared minus 5. Well, this is perfect because this is our vertex form again. So the vertex here is going to be negative 2 comma negative 5. And I get that because, remember, this is my first value here, but it's x minus negative 2, so it's negative 2, and minus 5, so my y value is minus 5. So this right here is our lowest point. Negative 5 is our minimum value. So that one's our minimum value. So this guy starts with a -1. That means it's going to be opening down, which means in this case, I'm going to be finding a maximum. Okay, so once again, I want to get rid of this 7 here so I can complete the square. So I'm going to have y minus 7 equals -x squared plus 2x. And I don't really want to be working with a negative out in front of my x squared, so I'm going to factor out that negative, and it's going to become x squared minus 2x. So this one's going to be a little bit tricky. Our b value here is -2, so I want to do half of -2. I get -1, and -1 squared equals 1. So I'm going to be, in this case, adding 1, except remember I took out this negative. So I have to remember, if I multiplied this negative back in, if I distributed it, this would be a -1. So I'm actually going to -1 from this side. So I'll have y minus 8 equals, and this becomes right here a perfect square binomial. It's x minus 1 squared, because -1 times -1 is 1, and -1 plus -1 is -2. So now I'm going to add this 8 back to the other side. So once again, I have vertex form. This negative here tells me that it's opening downwards. And my vertex in this case is -1, 8. So the one that's important here is my 8. 8 is my maximum value. It's the highest point of my parabola. Oh, I'm sorry, this is 1, 8. I forgot. So it's -1, that means it's +1, 8 for my vertex. Still doesn't change that 8 is our maximum value. All right, last problem. Interpreting forms of quadratic functions. They want to know which of the functions could be represented by this graph and explain. Well, the first thing I notice is this is a parabola that is opening downwards. So I'm looking for something with a negative a value, a negative beginning here. And I see this one has a negative, is multiplied by -1/2. Here I've got a factored out negative. Here I've got a factored out negative. This one looks like it would be opening upwards. I don't see a negative that's factored out, so this guy is automatically not a possibility. I also notice that my vertex for this guy is going to be somewhere up here in this first quadrant. It's got to have a positive x and y value to be this vertex. So I'm going to look at my vertexes here. So this guy's vertex would be at -4, 8. This vertex would be at 5, 9. This one, I don't know the vertex. This one's not in vertex form, so I'm going to not worry about that one for right now. These two, though, I can look at them and say, okay, 5, 9 could be that point right there. -4, 8 is not going to be the vertex of this parabola because that would be over in quadrant 2, so this one's out. This one's still a possibility. So I'm looking at this guy, and I notice that the x-intercepts here, the things that are going to make this guy equal to 0, would have to be x equals 2 and x equals 8. So right now that still looks good. This could be 2 and 8. So that one's not disqualified in any way. So it looks like we have 2 possibilities here for our graph. This g of x could potentially be the equation for this parabola. P of x could potentially be the equation for this parabola. I don't know, but both would work. So I would say either g of x or p of x is the equation for this parabola.